Okay, good morning, everyone. Today is our last lecture talking about introductory background concepts. The goal next week is to move forward with the programming languages. So next lecture, programming with C, and we're going to be working with C at least 2 weeks. So if you have the opportunity to read the books or explore a little bit about C programming, check the slides, it could be a good idea. If you can install the compiler, the environment that you're going to use to program with C, that could be also a good idea. So you can follow my examples and maybe copy paste to your compiler and verify that everything is working and you get the idea of what we are doing there. So the last thing that we need to review regarding background. I need to start with this, that is going to be a key element for C and C++ programming. What happens in the hardware when you run a program? What happens in your computer when you click enter and execute a piece of software? I am not talking about compiling. I am talking about running the program. Put the program to work in the computer. Let me do this step by step. Your computer have memory, and I am talking about the RAM memory, the big space that you have to running things. That space is connected with your CPU, and your CPU have a local space of memory. You know, instead of going to the RAM every single time, the CPU have this kind of small memory used together. Faster than the RAM, but smaller. Registers. Then your computer, your CPU, is connected with output devices and input devices. I am not going to show here the GPU just because we are not going to be doing GPU programming. So I really don't care if your computer, your hardware have or do not have GPUs. I am just going to imagine you are connected with an output device, your display, that's it. And you are connected with an input device, and I am going to talk about the keyboard, period. That is what you have. At least this is the architecture of the computer that I care about for programming. You're going to review more details in another class, but for us, this is what I care. Now, what happens when I run a program? Number one, the most important thing that happens is when you run a program, your program goes to the memory. You cannot run a program from the hard disk. Never, never, never a program is executed reading the instructions from your disk. The instructions of the program go to the memory. The first thing that the computer do is take your program, put your program in the memory, and then it's going to start executing instruction by instruction. Remember, matching code. What you have here in the memory now is matching code. And the computer is going to run your program, reading those instructions and executing the instructions. Well, I am going, let me answer the questions about the homework at the end of the lecture. Good. So we can follow up with the comment in the chat later. Step number one, put the program in the memory. The program, not the Java, not the C, not your source code, the machine language thing, right? Or the bytecode, assembly, whatever, depending on what you're working. Second, the instructions of your program are important, but more important, the data. And if you remember, you have two types of data in your program, two types of variables. Do you remember which ones? Variables in a program? You have what and what? Question in your exam, two types of variables. Type 1 is, type 2 is, in any programming language.
Global and local.
Yes, thank you. Global variables, there is a particular space and a special space for them in the memory. You have the code of your program and there is a particular nice space for the global variables. The global variables are together in a particular space. And then there is another space in which you are going to put your local variables. In this particular space, have a name. The name is the stack. In that space, every time that you run a method, your program is running, you run a method, the first method that you're going to run always is the main method. There is going to be a space inside of the stack to store the local variables that you create for the main method. But then, if the main method calls another method, whatever is the name of that method, inside of the stack, you are going to have a space, and inside of that space, you are going to store the local variables of that method, and so on. The stack. Maybe if you have a computer, you listened this name before, and in particular, you have listened that Stack Overflow. If you have a Windows machine and maybe sometimes you look a blue screen, maybe you look an error message, something about Stack Overflow. Can you help me to understand what is Stack Overflow? It's not the web page, it's a problem in your computers. Memory full, exhausted the RAM, yes. You know why is the name Stack Overflow? Because the memory that crash is not all your RAM. When you read Stack Overflow error, maybe all this space here is empty. What crash is the stack of one of your programs. One program is the responsible of this Stack Overflow. Why? Because that program overflow his stack. If we are in the classroom, each of you have a desktop. That desktop is the place in which you can put your things. That desktop is your stack, assuming that you are programs. And we all are in the classroom, and we all are programs running in the same computer, right? The computer can run several programs at the same time. So the classroom is our computer. Each of us can be a program. The desktop is our stack. And Stack Overflow means that one of us, one of you, put a lot of things in the desktop, and maybe your desktop crash. That is the error. Well, you can choose the program that you prefer as an example. But yeah, Chrome uses a lot of memory. Makes sense? Stack Overflow. One program, crash the memory. But please remember, it's not about the classroom crash. What crash is the desktop of one program, the stack of one program. And that is the reason of the Stack Overflow. is not RAM overflow or full memory overflow. It's the stack of one program. Anyway, the stack. Now, obviously, this is what you have. The green box is what you have for one program. Every program that you run, and you can run multiple programs in your computer, every single program is going to be something like this. The machine language code for the program that the computer, the CPU, is going to be reading from line by line. The global variables of the program and the local variables that are going to be in the stack. And obviously, we have a space for each of the methods that we're running. We need to separate the methods because we need to separate the local variables inside of each of them. That is the reason, because, for instance, you can have an X variable here, a box X, but also you can have an X variable in the main, and also you can have an X variable in a method X, because all of them are stored in different places. But you cannot have two variables X in main, or you cannot have two X global, something like that, because in that point you have a problem. You cannot identify one from the other. So, questions here, easy. Do we understand what is the stack? That is maybe the most important part, the stack. Good. One yes, hopefully that represents everybody connected. Excuse me. Okay, so next step. In Java, in particular, the second thing that I need you to know is when we talk about variables, we have globals, we have locals. This classification is about the scope of the variable, right? Where the variable is living. It's global, it's local, it's inside of a method, it's outside, it's inside of the class. There is another classification of variables. You have like the primitive variables, and you have the others, the ones that are not primitive. Help me, which are the primitive variables in Java? Yes, primitives. Do you remember which are those variables, primitive variables?
It's stuff like char and integer and yeah.
All of that, exactly. Primitive variables. If we talk about Java, we're talking about byte, char, int, long, char, double, float. All of those data types that you review in Java, they are the primitive data, the primitive data types. I am sure that you listened this word before. Primitive data types, primitive data, Boolean also, yes. All of them. In fact, all the data types in Java except one. Do you remember which one? The data type that you learned in Java in the first week or the second week is not primitive? Yes, string. Do you remember that this string have a particular feature that is uppercase, the first letter, and the people told you all the data types have this name that is a keyword and they are lowercase except the string? And I am sure that you discover what is the meaning of the uppercase string, right? Why the string have this uppercase S? Well, because it's the name of a class, and therefore you can create objects. Yes, string is a class. Classes are not primitive data. Classes are these non-primitive data. Do you remember which one are the second example that you have in Java for non-primitive data. Double is another class. Double con uppercase D is the name for the class double that is not the same as double with lowercase, that is the data type double. And I am going to show you the big difference. All the generics, all the classes are non-primitive data. So if you think about the string, double, chart with uppercases, all the collections, linked list, array with uppercase, and all the names of the classes, all the classes in Java or in any other language are going to be in this category of non-primitive data. But there is another example, another thing that are not classes or objects that is also non-primitive. And it's the last topic that you cover in CSI 110. Do you remember? Well, the structs are going to be for C. You do not have structs in Java. So the last topic that you reviewed in 110 was, yes, arrays. And I am talking about the arrays, those guys that have this with the name. I am talking about that arrays. Because the class array, there is a class with the name array, uppercase A is a class. You have the primitive data and the non-primitive data, classes and arrays, at least for Java. And I need to review with you why it's important that they are not the same. Imagine that this is the stack. This is, I copy here the box that is the equivalent to this one here, the blue box. So I do not need the full picture anymore. I am going to use only the blue box, only the stack. And maybe here I have the space for the globe. Let me tell you this, another concept. If my desktop is my stack, all the space in the classroom, all the space in the memory that I am not using, all the space that is not my stack, my desktop, is going to receive a name. That name is the heap. So again, my stack is like your desktop in the classroom. Every other thing, the desktop of your best friend, the desktop of the instructor, the floor in the classroom, everything else, you call it the heap. It's like the universe without you. You are the stack is your space. Everything else, the universe minus your stack, that is the heap. So the full RAM memory for you as a program, the full RAM is the heap, is this space out there. Now, what happens when you create in Java inside of the method main a variable, and that variable is a variable int x in Java, int x inside of the method main. I am not going to put everything, public static void main and so on. What happens when I have something like this in my program? Well, I am asking for a local variable. The local variable is going to be in the stack. In particular, it's going to be here for the main. And help me, what is a variable? Definition of variable is a question in your exam. Variable, a space in the memory. A space in the memory that stores something. Yes, thank you. A unit of the memory, a space of the memory. How big is the space in the memory to store an integer? in Java? 8 or 4? 32 bits, which means 4 bytes. Good. If I ask for this variable x, something that I need you to know, remember, is you are asking for something like this, 4 bytes. And those 4 bytes together are what you call the variable x. And those 4 bytes are inside of the stack. Those 4 bytes are in the stack in the particular space that we're using for the main. It doesn't matter which variable, global or local, you are creating, but for all the primitive data, what you are going to do is in the global or in the stack, a global variable x, if that one is an integer, you're going to have your 4 bytes there. Every primitive variable is going to be something like this: bytes from the stack, bytes from the global zone that you are going to be using. What happens when you put in that variable x the number 5, for instance? You are going to store the 5 in the variable. You're going to store the 5 in binary. The 5 in binary, something like this. Only 3 digits? Yes, 5 in binary, 3 digits. But your integer variable is 4 bytes. So you're going to have a lot of zeros. That is the reason because someone tells you, if you're going to use a variable to store like the age of a person, do not use integers because, well, the highest value that you're going to store is, I don't know, 100, something like that, 3 digits. And that is a very small number. And you are using a lot of memory, at least 3 bytes, that are going to be always 0. But we're going to talk more about it. Anyway, this is what happened with a primitive variable. You have the bytes, you store the value in binary, and that's it. Nothing special. Now, classes and arrays, they are different. Why they are different? Well, always, 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 when you create an object in Java, the objects in Java are going to be in the heap. Always, 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 when you create an array, your array is going to be in the heap. But what is going to happen if I am creating my array, like my array R, and I am creating my array in the main? I create an array in the main. I want to have my array like a local variable in the main. Well, what you have in the main is this variable that is going to store the address of the first element of your array. What happens if I create an object in the main? You know, I have the class student and I am going to create a variable S. And I am creating an object that is from the class student and is an object S, and that the student have the name and the grade and other things. Well, you have something in the main. You have the address of where the object is, but the object itself is going to be created in the heap. Do you remember the name for these variables here, this variable here, that store the address of the array or store the address of the object. Do you remember this name for this particular variable? Well, pointer is going to be the name in C and C++. Yes, in Java in particular, you talk about references. Arrays and objects in Java, they are references. References. Because this is not the object, it's just a reference. Later, in the other languages, a pointer, because the action of pointing to the real object, to the real array, because the objects and the array do not live in the stack. The objects and the array lives outside. Why? Well, the same reason, because if you have a car, you put your car in the parking lot, not in the classroom, because they are too big. And if we put the cars in the classroom, we do not have enough space. If we put the objects or the arrays in the stack, we are not going to have enough space. We're going to have this overflow too quickly because arrays and objects are big. So the rule is only primitive data go to the stack, and the data that is not primitive, objects and array, the ones that are large, they are going to be outside. But you are going to have here a reference that is kind of, you can have in the classroom the keys of your house or the keys of your car, but the real car or the real apartment, whatever, is outside the classroom. And again, the classroom is kind of our RAM memory, well, our stack. Your desktop is your stack. So you have your keys in your desktop. Make sense? So heap, stack, reference, primitive data, non-primitive data, global and local data. Those are the concepts that I am going to use for your midterm. All of them are clear. Question in your exam, why we put objects in the heap and not in the stack? What is the difference between the heap and the stack? Fine? No questions. That is great. Okay. So now I can go back to the slides, and now I can show you this picture, and this is the picture of how a program looks like in the memory. What is this? You have the stack, and each of these boxes is a method that is running. We can agree that when you run a program, always, 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 at least the main method is running. The main method never finishes. When you finish the main method, your program finishes. But the main method can run a second method, and this method can run another one. And when this finish, you go back here, and when this finish, you go back to the main, and when the main finish, the program finish. That is the reason because you have this picture of a stack. Always in the bottom part is the main, and you cannot remove or eliminate any method without finishing those that this method run. So you cannot finish the main until all the methods in the program finish. So the last one to end is going to be the main. When the stack is empty, your program is done. In the memory, when you have these arrays or objects, something that is going to happen, and hopefully you're working in data structures, is, well, you can have a reference to something that is maybe an array, and that array can be pointing to another array just by a chance. And hopefully at this point, you remember, or you have the opportunity to review two-dimensional arrays. And hopefully you remember what happened with 2D arrays. 2D arrays are this idea of one reference to an array, and each of those elements is pointing to data. This is the picture in the memory of a 2D array, 3 columns and 3 rows. This is what you imagine, the 3 columns, 3 rows. But the real representation of that, the real situation in the memory is you have another array that is an array of references, each of them pointing to one line in this 2D scenario that you imagine. And you have another reference that is pointing to the first reference of the array of references. Don't worry, we're going to talk about this in more detail. But my point is, what you draw as a 2D array, very fancy and nice, do not exist like that in the memory. In the memory, a 2D array could be something more crazy like this. Moreover, you can have a reference, and that reference be pointing to an object. I draw the objects like circles, and maybe your instructor in 110 do the same, objects like circles, but the circles do not exist in the RAM. In the RAM, everything is a group of bytes. So this can be an object, and this box can be all the elements in the object, just plain. And this one, the object, can have inside an array, which basically means this other box and this other connection, pointer, reference. So what you have is a lot of boxes connected with a lot of lines. That is a program running. Moreover, you can have multiple lines, like multiple references to the same place from multiple methods. More than one method can access the same information in the heap, just having the address, having a reference. And we're going to play a lot with this. Maybe these pointers, references, is going to be the most important topic that we're going to be reviewing during the full class, because we're going to use 2 programming languages to talk a lot about these lines in the picture. You already know about them, but we are going to go into the detail about what is happening. Anyway, at this point, the stack, the heap, the global, the local, the primitive data, and the references. Clear. The big picture, at least. Any question? No? Good? Perfect. So, moving forward. This is what happened in the memory. Now, I want to describe what happened inside of these small boxes for primitive data and also for references. What happened in the boxes? What are those blue, green things there? What happened in these 4 bytes that we described for the integer? Well, what happened is the following. If you remember, every single time that you create a variable, doesn't matter if the variable is primitive or non-primitive. Always, 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 your arrays, your objects, your variables, primitive data are going to have a data type. Always, in Java at least. Reference to reference is something that you're going to use to create a 2D array, but it's not the only thing. But yes, always a 2D array is a reference to reference, a 3D array is a reference to reference to reference, and you continue. Every time that you add a dimension to an array, you add a new reference to the sentence. It doesn't matter which data you are representing. Always, always, always you have a data type. And the question in your exam is, what is a data type? two things that I want you to know, remember, and be able to answer. The data type is the one that defines the size and the format of the data. Size and format. Every single time that you put a data type to a variable, what you are defining is the size and the format that is going to be used to store data in that particular variable. When you put int to a variable, this is the data type, and that one is defining that what you're going to call x is going to be a space that have a size 32 bits, or I am going to use bytes 4. But you know that each byte is a group of 8 bits, right? So 8 zeros or ones, in total 32 digits, zeros or ones. And those 32 are going to make the information that you can store in the variable. The data type is the one that defines the size. So if I create something like a byte, is a data type in Java, A, I am telling that my variable A is going to be used one of this, 1 byte, 8 bits. Okay, the size. Second, the format. The format. Yeah, because do you remember float in Java? Help me, what is the size for float? How many bytes in a float? 4. So the data type defines the size, but also the format. What do you mean by the format? Well, for instance, you have integers and you have floats. They are the same size. They both, integer and float, are 4 bytes. In terms of the size, they are the same. However, with the floats, you are able to store the integer part and the decimal part. And with the integers, you do not have that. Well, that is because the format of the information. That is because how do you store the information? What? Yeah. Size, the same. These two, example number 1, variable integer equal 3, example number 2, variable j equal 3.0 with the f in order to use float, not double. Same size. Both have these 32 bits, both. But the format that we follow is a little bit different. For the integer, what we do for the integer is any value that you put here in decimal, the computer translates to binary. Hopefully you are learning binary and you can translate any value to binary. But when you translate the 3 to binary, this is the 3 in binary, 1 and 1. And all the other bits go to 0. Well, wait. All the other bits go to 0 except this one, the first one. That one is going to be plus or minus. 0 is plus, so the number is positive. 1 is the minus, so if I put a 1 here, I could have a minus 3 instead of plus 3. That is what I am talking about the format. Is the only thing that I have is zeros and ones, but what I do with those zeros and ones is going to tell me what kind of information I can store. I am going to use the first bit in order to store positive and negative. I am going to use the others to store the number. What is going to happen with the float? Well, with the float, I am going to do something different. With the float, I am going to use from my 32 bytes, the first one, to store positive or negative. The same thing that I did with the integer. But now, the others, I am going to use some of them to store the fractional part and others to store the exponent. I do not want to play a lot with this, but hopefully you're familiar with this notation of 3e2 or 3 minus 2. I am using the e for the exponent, whatever, but what is this and what is this? Well, you have one number for the sign of the base, the red numbers, and you're going to use another one for the sign of the exponent, the first 0, 1 in the blue ones. So you have kind of both positive and negative exponent and base. So in this case, I am using the positive 3, but I am using the exponent positive and negative. I want to be sure that we understand what is the difference of the positive or negative in the exponent. The exponent is going to tell you positive or negative, whether you move the point from the numbers to the left or to the right. So you can have a 3 with an exponent positive, and what you are doing is to move the dot, which basically means a 3 can become 30, 300, 3000, and so on. Or you can move the dot to the opposite place, and that means that the 3 can become 0.3, 0.03, and so on. That is what you do with the decimal numbers. That is how do you store floating point numbers. 25, 2.5, 0.25, 0.025. All those examples, in terms of the floating point number, is the same base. It's the same 25. The only thing that I need to change, the only thing that I need to store different is the exponent. Is the exponent nothing? Is the exponent moving 1 to the left? Is the exponent moving 2 to the left? Is the exponent moving 3 to the left? Or maybe what you want is 25,000, and therefore the exponent become positive. The only thing that I need to do with a floating point number is to store, in this example, a base of 25. And the only thing that I need to store here is one of these numbers, and my result is going to be any of these possibilities. Think about it. If you can store the 25 and you can store, for instance, a 3, you can represent with this format a number that have something, I don't know, like this. And if I put here 10, you can represent a number that have a lot of zeros after the 25. So with only 2 places, with only 1, 2, 3, 4 digits, you can represent a number that is going to have 10 digits. The format. That is what changed, and that is what you do when you represent floating point numbers in the computer. And that is the reason, because even though you have the same 4 bytes for integers and float numbers. When you review the size of an integer in Java, the small number that you can store is -2 exponent 31 or +2 exponent 31. And with floating point numbers, you can store from this to this. And if you try, these numbers represent 38 positions, positive numbers for more than 30 digits, theoretically, in the positive size, I mean, integer part, or decimals, theoretically, versus the common integer that is use this or this, because the format. Makes sense? Now, in this class, I really don't care about you understanding the format. The format representation is something that you review in a different class, in a class in which you review the hardware. And this one that I explained to you is a really old format to use. Obviously Java, this one is more like C, C++. Obviously in Java, you adjust some things, but this is hardware. The only thing that I care about in this class is that for you, it's clear that when you choose the data type, you are choosing the size, but also a format. And the format is going to change what you can store inside, not only the size itself. And the classical example is this comparison between integer and float numbers. Same size, not the same values. Make sense? Like what? What is a data type? In your exam, data type is the one that defines the size of the format of the data. Good. Tell me, what happened with the data type when you create an array? What happened when you create something that is going to be like integer, that is an array, but because it's going to be an array, you do something like, I want 3 elements. This is the data type for what? Well, that one is the data type that you are going to use for the first element in the array, for the second element in the array, for the third element in the array. What happens if I put in the array in the position 0 the number 3? Well, this one is the first element, that one is the position 0. You can store the number 3, that basically is 1, 1, and all the others 29 positions are going to be zeros. What happened when I put in the array in the position 1 a number 1? Well, this is going to be the number 1, and all the others are zeros. The number 1 in binary is just 1. What happened when I put in the array in the position 2 a number 5? 1, 0, 1, and all the others are going to be zeros. And this is my array. 3 times 32 bytes, and here is my number, here is my number, here is my number, and all the others are just zeros. But remember, every single time that you create an array, you have your information. Where is this information? In the heap, right? What you have in the stack, if you create this, for instance, in the main method, in your stack, you are going to have a variable that is a reference, and that reference is going to have what? the address of the first element, the address of this first byte in the first element of the array. Because remember, every single byte in your memory have an address. You have 5 gigabytes, 10 gigabytes, whatever. You have basically every single byte with an address. Every single byte have a number. So in an array here, you are going to store the address of this guy. If that guy is that address, by the way, you are going to use hexadecimal to represent the memory addresses just because you do not want to use binary. The reference store that address, and that is what we call a reference. I have the address, I have the key, I know where the information starts, and I know that the information has size 3. So if I am pointing to the first one, it should be 2 more, and I know that they are integers. So the first one is 32, the second should be 32, and the last one should be another 32 bits. Therefore, I can access them one by one. And we're going to play with pointers, and it's going to be fancy, yes. Makes sense, guys. Good. So, data types, the format, and the size. Okay. Now, when you have variables, and your variables are from different data types, like, again, I have an integer, x, and I have a float, y, and I put here a 3. Therefore, I have this data like this. And then I want to do this float y equal x. Okay, I am going to have my variable y. That is the same size that my variable x. Can you imagine what are the implications of doing this? Y equal x. Because if I do int whatever equal x, this one is basically copied byte by byte from one variable to the other. If you have two variables from the same data type, is the same size, copy the data bit by bit. But if you have different data types, like this example, the only thing that usually we think about it is, well, this is a float, the float should be bigger, therefore it should be correct that the x can be stored in the y. Yes, but hopefully now you agree with me that in order to do that, the computer need to fix the things. When the computer adds 3.0 to your tree, what is going to happen is, well, this 0 here is going to be the same 0 here. But then, in order to make this tree a float, the computer is going to put here an exponent value and is going to copy all of this, but in a small space. In this case, the good news is use a tree. And what I want to tell you is, in order to copy the tree from integer to a tree float, at least one byte here is different. Because now the format for the float is, yes, the number, but the number is just one part of the information. Yes, the sign is one part of the information, but now we need to define the exponent, and we need to use some bits for the exponent. And in the simple scenario, you have an exponent 1. The computer needs to figure out that. if you have here as an integer 350, well, the computer needs to move the data, the 3 and the 5, and figure out what is the best representation for the 350. An exponent 1, an exponent 2, make the conversion, and then you can do this. Always, 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 when you work with variables, and those variables are from different data types, a conversion is happening, always. Now, that conversion can be implicit or explicit. You already know the explicit ones. They have a name. You know the name. What is the name when you explicitly ask the computer to transform one type to another? Casting, yes. When you ask, it's casting. But when you do not ask, the casting is still happening, like in this example, because there is a transformation between the format of the integers to the format of the floats. The computer is doing the transformation for you because the computer supports this expression, this semantic. In that moment, the computer takes the responsibility of translating this to this. Well, not the computer, the programming language. And we're going to review that some programming languages do this, like Java, and other programming languages are going to tell you, this is your problem. We need to review the different options. Just be aware about this. Now, two scenarios. You can have this transformation or you can have this equivalence in two ways. Number one, you can have data type equivalence. I am talking without casting yet. You can have data types equivalent because they have the same structure, or you can have data type equivalence because they have the same name. What? Yeah, let me show you. Here. Line number 1, correct or not? In Java. Can I do hello plus 5 in Java? You can do it. Yes, that is going to give you. If you want to try, you can do something like that. Print hello plus 5, and it's going to give you hello 5. Why? What happened there? We do not ask for a casting, but what happened? What Java did with this? Semantical rule. Always, 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 Java, if you try to add something to a string, Java is going to transform the something to a string. And then after transforming this to a string, it's going to put the two strings together. Some transformation is happening. You didn't ask, but the transformation is happening. The 5 become a string, and then you are putting together the string hello and the string with the 5, an implicit transformation. Yeah. What about the second line? Correct or incorrect? Hopefully the red color helped you. It's wrong. Why is wrong? The first thing is, I am adding a boolean with hello, or I am comparing if 5 is greater than the string 7 hello. Which of these two operators happen first? CS110, right? Go ahead.
I think it's the addition first.
Yes, you are correct. Do you remember arithmetic operators and relational operators? Which one have a highest precedence? The arithmetic. So the first thing that happens is the addition. The first thing that you do is 7 plus hello. The second thing that you try to do is to compare if the result of this is lower than the 5, or if the 5 is greater than the result of that. And that is something that you cannot do. These have an error. The error is here, because you are trying to compare an integer with a string. There is a casting. The computer did a transformation. The 5, in this case the 7, to a string in order to add with the other string. The plus happened. But then the computer cannot continue with the comparison of greater than between an integer and a string. And in that point, you have the semantic error. Yeah, the plus goes first. Now, next line. What about this one? Can we do that? Yeah, that is correct. We can do that, right? Number plus number. This is going to be a number. Can we store a number in a variable that is a char? Yes. The format for storing a char, you do not store in the memory the letter A. Never. What you store in the memory is a binary number. And then you have something, the Unicode table or the ASCII code, whatever. And you have this equivalence between a particular number and a particular character. But the char variables, they store numbers. So if I store this, it's going to work. And if I store something between single quotation marks, what the computer do is go and search that character in this table that the computer knows, Unicode or ASCII, and store not the character, but the number that is equivalent to that character in that table. Good. Okay, question in the chat regarding the order in integers and strings in Java. Check which version are you using. If you're working with Java 8, Java 9, now the order can be work in both sides. 7 or older releases of 8 only work if the number is in the right part and the first one should be a string. That is something that they change. Oh, big parentheses. Now, I am assuming that you know the 8, so that is the reason, because I mentioned like a string plus number doesn't matter. This one, why that one is an error?
It needs an F at the end of the number.
Well, the reason is because these two without the F is a double. Do you remember what is the size of a double? Twice the float, right? So what you have is this number 2, that is the 10 in binary, stored like this in 64 bits, in which you are using zeros in 60 bits, and the last two are 1 and 0. And you are trying to store that in a float, and the float is only 32, half of the size. And the computer is going to tell you, you know what? It doesn't fit. When you put the F, the only thing that happens is, okay, put here and copy half of the number. And now you can copy the 10 here, the number 2. Format. Double. Can I do this? The A in an integer. Sure. Have you tried a character, whatever, in an integer variable? You could be surprised about the result. Try. Try for your exam. Now.
Excuse me, can I ask a question?
What?
Can I ask a question?
Yes, please.
Can you go back to the previous example of integer to float?
This one?
Yeah. What happens here if we have the maximum size integer, like the biggest number? Aren't we going to be missing bytes to be translating it into float?
Yes. Something that I didn't mention, you can imagine, even though the minimum and maximum are for the integers kind of smaller. The first element and the last element looks like they are smaller than the one that you have with the float. The reality is that you have a highest precision with integers than the precision that you have with float. Let me be clear. How many digits can I have with integers? There, I have 10 digits. And any number that I store between the first one and the last one, always, 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 I am going to be sure that the 10 digits that correspond are going to be there. Do you remember how many digits you can store in the float? The big issue with the float. How many digits with a float? How many digits with a double? Do you remember? Decimal numbers with double, decimal numbers with float. 7 with the float, 15 with the double. And we can be thinking like, wait, are you telling me that we are going to have 10 digits, even though the minimum and maximum are kind of very, very narrow with the integer? Yeah, because you are storing the real number. You are storing the number in binary, the real one. And you are telling me that even though the float have the same size as the integer, you only can store a total of 7 digits somehow distributed. Yeah, you are going to lose precision because the floating point, yeah, is going to give you a maximum range of values, but there are a lot of issues with the floating point numbers in the hardware of a computer. And again, that is something that you're going to review in your hardware class. What happened with the floating point numbers in the hardware? It is not true that you have access to all the possible combinations here. It's not true that you have access to all the digits with any possible variation. You have access to a maximum of 7 digits. When you have a number that have more than 7 digits, you are going to lose precision. And the same happened with the double, and the same happened with the float. Makes sense?
Yes, thank you.
Okay, good. So going back to the data types. 2 options for the data types regarding the casting. The things that we review with Java, all these examples, in sometimes Java do the casting without you asking, just because Java have those kind of casting rules inside. Java take those decisions for you and doesn't matter the name of the types. Hopefully you agree, this one probably is going to work. Java decides that integers and char can move back and forward. Java decides that this can work. Java decides that here is going to try to do the addition. Java in particular do the addition for strings. Good. Now, some languages do not do that. And for some languages, I want to show you this example. Think about Java, and I am going to use classes just because it's one way to create new data types. But think about this example. Imagine that you have a class, foo, and that class have an integer array of 100 and an integer alone. What is the size of an object from the class foo? Total size. With what we review now, we know that anything like that object is going to be a group of bits and bytes. In this case, how many bytes? 32, 100 times. Each integer is 4 bytes, right? So let's talk about bytes just to make it this small. So if each integer is 4 bytes, then I have 100. Could you agree about 400? But then this is also 4. So can you agree that I am going to have something like 404 bytes? And that is going to be kind of an object from foo. And again, it's a big collection of bytes. The representation as like a circle is just a fancy way to explain things. But in the memory, the circles do not exist. So that is foo. Now, think about this class bar. In a class bar, I am going to put the same, an integer, an array of 100, and I am going to put an integer that is just 1. If we think about an object from the class bar, can you agree with me that they are exactly the same size? If you look at the memory, can you agree with me that if you saw an object foo or an object bar, they are exactly the same size, moreover, the same type? You have 404 integers, one way or another. Now, if you are working in Java, and if you create in Java X and Y from the class foo, and R and S from the class bar. So imagine that you create those 4 objects. I am not giving you the new and all the program, but just imagine that those objects exist. Hopefully you agree with me that in Java, you can make X equal Y, it's going to work. And you can make R equal S, it's going to work. You can make equal 2 objects from the same class. Hopefully you did that in 110. But what if you try to do something like this? An object from foo is equal to something from bar. Java is going to tell you that that is an error. But they are the same internally. But they do not have the same name. And Java in particular, Java have these rules with the primitive data. Java allows you to do a lot of things with the primitive data. But in Java, when you move from the primitive data to the complex data, like the objects, Java, the only thing that Java consider equivalent are the things that are from the same type. So in this example, even though they are the same in size and the same in the internal composition, because this one, the name of the class is foo, and this one, the name of the class is bar, they do not have the same name. Java is going to tell you that is wrong. Same size, same types. The only thing that you need to do is byte by byte copy down. Java do not do that. It's an error. They do not correspond to the same class. This is name equivalence, and that is what Java use for the non-primitive data. The good news is that there are other languages in which you can do this too, but also you can do this. There are other languages that is going to take the time not to review only the name of the class or the data, but go inside and check if the structure match. And that is structural equivalence. Make sense? name equivalence, structural equivalence. Telling you that you have an error just because the name of the types are not the same, or taking the time of review if something can be done. This is with the language itself. The last one, type conversion. As you mentioned before, if you ask for the conversion, you are doing casting. Just remember that word, you already know it, casting. The action of asking for data type transformation is casting. When that transformation happens without you asking, like in this example or in those examples, things just happen without you indicating that you want to do the transformation. As in this example, float x equal 5, and you are doing the transformation of the integer to the float. The change is happening because they have different format, but you never ask for a casting like something in parentheses, remember? The name for that, the opposite of casting, when the computer do the casting without you asking, the name is coercion. That is the implicit casting of data types. So casting and coercion, two concepts that I need you to remember. Implicit conversion here, because this is an integer, and before doing the operation, I need to transform. I cannot do the operation with two data in different formats. I need to put both in the same format. Casting in Java, when you use this thing and you ask for the transformation, maybe of the float to int, so you reduce and then you add with an integer and you can store in an integer. Asking, do not asking. Implicit, explicit, casting, coercion, and that's it. Any question? See you next lecture. Thank you.